Today I will deal with another aspect of sedimentology which we call sediment granulometry. That means what are the characters of the sedimentary grains and how they are represented. The outline of the talk is given here. We'll talk about the sediment grain properties, the size distribution of the grains, grain size scale and the parameters which are used to define grain, then application of the grain size data, then what is the shape of the grain, types of signification sorting, the statistical methods like cumulative probability, different parameters, statistical parameters, roundness and sphericity, and finally I will give a summary of the talk. Sediment grain properties. This involves identification. That means identified what mineral it is, whether it is a quartz or a feldspar or it is mica or iron mineral, the identification. Measurement, you have to make the measurements, whether they are long or tall or small or big or round, etc. And interpretation of different type of sedimentation. This also finally involves statistical treatment of the granulometric data. That means statistically we will treat the data of grain size, grain shape, and all other and the properties like roundness, sphericity, all these things will be treated statistically. How the grains are distributed? Grain distribution this can be quantitative. If you want to make it a quantitative expression by weight of the constituent grain size, these can be expressed either in the form of the grain diameter or by volume. They can be either very coarse, they could be medium, or they could be fine. Woodin and Wentworth, they are the two sedimentologists who proposed a grain size scale in which they gave equal significance to the size ratio in all grain types. They thought that each successive grain size is half as large as the previous size. That means 1/4 to 1/3, 1/2, the second to 1/2 to 1 to 2 or 3 and 4 like that millimeters. On the other hand, there is a scale called phi scale, was given by Crumbin as an arithmetic scale 1, 2, 3, 4, like that. This phi scale is a logarithmic based modification of the Woodin-Wentworth scale. In this case, the diameter in millimeter is converted to a dimensionless unit called phi, which is minus log 2d. This is a pictorial representation of the Woodin-Wentworth grain scale. You can see here there is on the top is given silt, very fine sand. The nomenclature is silt, very fine sand, medium sand, coarse sand. Then we have a very coarse sand, granules, then smaller pebbles, and then you have finally cobbles, and then finally become boulders. 256 millimeter is considered as a end maximum of the cobbles, and then it becomes boulder. On the other hand, the phi scale is defined as 60 like different mu in mu 63 mu, 95 mu, 125, 187, 250, 375, etc. About 200 mu and like that. So you have two type of scales which have been shown here as a comparative chart. How do we measure the grain? Measuring grain side, the choice is the rock dependent. That means what rock it is, whether it is a quartzitic rock or whether it is a sand, scaly rock or the coarse sand or a pebbly sand. Therefore, it will depend on the method, the rock dependent. The unconsolidated sediments, which are done by manually, you just take either by just measurement by vernier calipers or you use the standard sieve methods, by which you sieving through different size of sieves with different mesh size, and then you can say that different mesh size has got these type, so much quantity is remaining in that particular sieve. On the other hand, silt and clay, which are very fine, they are they are treated by elutrition method. They are called settling tube. There is a big glass tube in which water is filled up to a particular level, and then the sediment is added to that silt and clay, and they are the entire group unit is shaken, and then it calculates the settling time, the time it takes to settle at the bottom. That is calculated, and then you make the grain size determination. On the other hand, the consolidated sediments you do like hard rocks, you take thin sections, take the microscopy, and then grains are measured by point counters. Now, point counters, there are nowadays there are point counters which are automatic point counters, which are inbuilt in many of the microscopes. Uh, Otherwise, earlier it used to be a very cumbersome process of looking at each grain and then taking the measurements. Now, the grain parameters are there. There are two main parameters, mode and median. Mode represents the highest point or peak of the frequency curve. There could be either unimodal, could be bimodal, or it could be polymodal. Median is the size of midpoint of the grain size distribution. That is, half the grain are coarser and half are finer. They correspond to a point where 50% line intersects the cumulative curve. The grain size barrier, as I told you just now, the mean is the arithmetic average of all particle sizes sample. The sorting of the grains, which is also called standard deviation, is a measure of variation of grain size. It reflects the impact of post-depositional processes. They could be well sorted, they could be moderately sorted, or they could be poorly sorted. So using a 5 scale, which is non-logarithmic, is very easy. It is easy because it allows plotting on normal arithmetic paper instead of a log paper. Therefore, the shape of the curve is much simpler to interpret than what you do in log paper. Statistical parameters are also conveniently interpolated. Similarly, boundaries between different size units are in whole numbers, not in fractions. This is the particle size scale which is given here, which I have shown you in Wentworth grayscale. Like boulder is more than 256 millimeter. In 5 scale, it is less than -8. Like this is the scale here: cobble, pebble, granule, very coarse sand, medium sand, fine sand, very fine sand, coarse silt, medium silt, fine silt, very fine silt, and clay. And these are the corresponding sizes in millimeter and in 5 scale. It's given in the type table. They lead to formation of rocks which we call as a gravel or a sand or silt. And they produce rocks like sandstone, conglomerate breccia, siltstone, mudstone, like that. The fine particle clay materials produce mudstones, while the silty material from siltstone. Mostly sand-sized particles give you sandstone, and while coarser material give you mainly the conglomerate. Breccia is often used as a part of sedimentary rocks, but many times breccia are of tectonic breccia, so one has to differentiate between the tectonic breccia and the sedimentary breccia. What is the application of grain size data? Application grain size that we can use terminology to define a rock. We also can find out the source of sediment grain, that means the process, how sediment has formed. How it has formed, given rise to porosity and permeability in the rock, because this has got a direct implication on many commercial activities, especially in petroleum and water reservoir, where porosity and permeability are important factors to tell the transmission of these fluids. And this also tells us how the depositional environment existed during the formation of the ancient rock. The use of grain size data, we use it for classification of plastic sediments. To understand the rocks and depositional processes, to measure the porosity and permeability, and to interpret the depositional environment. Then we come to another property from the size, we come to shape. It describes in three-dimensional forms and measured by a ratio of long, intermediate, and short axis. So grains could be spherical in shape, it could be prismatic, or bladed. Sedimentologist, sedimentologist Jing, he classified these rocks based on relative length of longest, shortest, and intermediate axis. The four basic types of particles are, as I told you just now, tabular or oblate, equant, bladed, or prolate. The rocks are also get sorted. They get sorted if they are well sorted. That means grains are of almost similar size, near similar size, and they are called well sorted. They are moderately sorted means some big grains, small, other smaller grains, and poorly sorted then were very large grains and very small grains. They're called poorly sorted. Sorting is defined by three types: poorly sorted, moderately sorted, well sorted. Now these graphical techniques, if you see the x-axis is the grain size and y-axis is the grain percentage, so you get this shape. Well sorted grains give you peaks, moderately sorted give you a small peak, and poorly sorted give you a flat peak. The significance of sorting is a property called skewness. Skew means how the sediments are deviating from a particular specific position. Then there could be negative. For example, one here is a negative, that is negatively skewed. If you have no skewness, no changes, then you call it none. And if it is positive, it is more towards the right side, then you call it more. When you call positive. The knowledge of sorting gives us the clue to the energy conditions of transporting medium. They also tells us about whether they were deposited by high velocity currents, like a desert or beaches or shallow seas, and as a result of that, these sediments are better sorted. On the other hand, sediments which are formed by storms or mud flows, they produce gravels and fine silt, and they show poor sorting, and we call it poorly sorted. Graphically, this can be shown either in the form of a curve, frequency curve, or by histogram. You can see here the phi scale is given on at the bottom is the phi scale and the frequency on the other side. So you can get a peak like this. The cumulative arithmetic curve, cumulative probability curve, or cumulative arithmetic curves give you like this. You have a phi scale on this and percentage on the other side, and you have got a probability curve has got this particular shape, while the cumulative arithmetic curve have a slow, very gentle slope. The use of cumulative curve is that the shape of a cumulative curve tells you it gives you the information about the mode of sediment transport, such as whether they are formed by traction or by rolling or saltation or by suspension. And the slope of the curve is a function of sorting. Steeper the slope, better is sorting. Then another characteristic, as I told you just little before, the skewness. The skewness is a measure of the degree of symmetry of the size distribution. I repeat again, negative if the distribution and a coarse tail, that is excess of coarse material. If there is distribution is symmetrical or bell-shaped, we call no skewness. And if it is positive, it is called excess of material. What does it tell? It tells that it reflects the depositional process. For example, beach sand. Beach sands always show negative skewness, since finer sediments like silt and clay are removed by the wave action. On the other hand, river sands are positively skewed as their finer components are not removed by the currents. Another characteristic of sediment is kurtosis. It is the degree of peakedness or the departure, that is, it is a spread of curve peakedness from the normal frequency or a cumulative curve. It compares sorting in the central portion of the population with that in the tail. This is a kurtosis curve. There are three types of curves which you can see. A normal curve is a bell-shaped, like the red color it's called leptokurtic. In the middle you see the peak is called leptokurtic, and black one is a platycotic. These are some of the formulae which we use for describing the doing the statistical treatment of the data. We find out graphic mean. Graphic mean is 516 plus 5 to 5 plus 550 plus 584 by 3. Inclusive graphic standard deviation is 584 minus 516 divided by 4 plus 595 55 minus 55 and divided by 6.6. The inclusive graphic equation, the skewness is defined by 516 plus 584 minus 2550 divided by 2, 584 minus 516 and plus 55 plus 595 minus 2550 divided by 2, 595 minus 55. And graphic kurtosis is defined by 595 minus 55 divided by 2.44 divided into 575 minus 525. The statistical parameters are given by Folk and Ward. They describe the grain size distribution using only percentile taken from cumulative frequency curve. For example, 550 is referred to as 50th percentile of the sample. That is, grain size of the sample at 50% read from the cumulative curve is 1.55. Roundness is another characteristic, is called rho, is a measure of smoothness of particles. It refers to how smooth or sharp the edges and corners of particles. It is expressed as, you can see, the rho is equal to, this is individual radii of grain outline, radius of circle equal to grain size, and number of curvature in the grain outline. There are 6 categories of roundness: very angular, angular, subangular, rounded, sub-rounded, and well-rounded. There is a RL Folks roundness scale, visual scale, where you can the grains roundness can be compared by these, and then you have very angular, angular, sub-rounded, rounded, and very rounded. The next characteristic is Waddell defines sphericity as the ratio of the particles ratio to the area of a sphere with the same volume. The two-dimensional sphericity can be computed as given here, where D1 is the diameter of the largest inscribed circle and DC is the diameter of the smallest circumscribed circle. There is a comparative scale, roundness and sphericity together. You can see the high sphericity, low sphericity. You have, as you go up, there is a high sphericity. So there a relationship is given here, the roundness and sphericity comparison. To summarize what we discussed today, identification, we have identified, measured, and interpret the different types of sedimentary grains. We discussed grain size distribution, which are coarse, medium, and fine. We discussed Wooden-Wentworth grain size scale, the 5 scale given by Krummein Wooden-Wentworth grain scale, and the grain size scale and other parameters like mode, median, mean, and sorting. We also studied the application and use of grain size data. We discussed grain shape, whether they are spherical, prismatic, or bladed. We also said what type of sorting they are, whether they are poorly sorted, moderately sorted, or well sorted. We also discussed the significance of sorting. We also discussed the cumulative probability and use of cumulative curves. We discussed various statistical parameters like skewness and kurtosis. We finally spoke about roundness and sphericity. Thank you very much.